Lesson 4 of the hyperbolics pack is concerned with differentiating hyperbolic functions, which in some ways is easier than differentiating trig functions. It turns out that if you differentiate sine and cosh, you just get the other one without any sign changes. So, for example, differentiating cosh x, well, we know cosh x is e to the x plus e to the minus x over 2. If we were to differentiate this, differentiating e to the x stays as e to the x. Differentiating e to the minus x goes to minus e to the minus x, which should look familiar to you, that's sine x. Have a go at sine x yourself. You can pause the video and then I'll reveal the answer. But it does the same thing. So differentiating the minus e to the minus x goes to positive e to the minus x, which is just cosh x. Similar results hold to trig as well. So if we're differentiating than x equals sec squared, we can do it by using the quotient rule. Because you know how to differentiate sine and cosh now. The quotient rule says if you differentiate the top, you get cosh x and times by the bottom. Minus differentiate the bottom, which we know gives us sine x now, and times by the top, which is also sine x. And that's all over the bottom squared, which is cosh squared x. Tidying this up a little bit, so cosh squared x minus sine squared x over cosh squared x. The top of that should look familiar to you as an identity on the formula sheet, which is equal to 1. And although I don't think we mentioned it in the pack yet, 1 over cosh squared x, well, 1 over cos x is sec x. So in hyperbolic terms, 1 over cosh x is sec x. So let's give you sec squared x. These results are given on the formula sheet, so you can just quote them when you're differentiating. You might have to use product rules and chain rules and quotient rules and stuff all from A-level maths to make sure your A-level differentiation is good. But they shouldn't be too bad. So we're going to use the product rule to differentiate this one. First thing, differentiating the first function gives us 2x times by the second function gives cosh 4x. And then differentiating cosh 4x, or cosh just differentiates to sine. So that will go to 4 sine 4x from chain rule and times by the x squared. And we'll write that as 4x squared sine 4x. Have a go at this one. It will require you to use the chain rule and the product rule on this one. Pause the video and then I'll reveal the answer. Using the product rule, you differentiate x to give you 1 times by sine x cubed. Then you differentiate sine x cubed. That gives you 3x squared cosh x cubed and then times by the x. Note the cube's on the x, not on the whole thing, because there's no bracket around them. We're going to differentiate this one twice. So first off, dy by dx for this one. So a cosh 3x, well, chain rule times by the 3, and cosh goes to sine. Same for the sine, that's going to go to cosh, 3b cosh 3x. And if we differentiate again, times by 3 again gives me 9a cosh 3x. Differentiating cosh goes to sine, and we times by the 3, so 9b sine 3x. We can factorize out the 9. And you recognize this as what we had originally as our y. So we've proven the result. You might get asked to work out tangents, normals, stationary points, and stuff, also from A-level maths, but with hyperbolics. So here we're asked to find the equation of the tangent to this curve, sine of ln of 3x plus 1. There are things you could do with this. So I'm going to do it as it is, but you could simplify this using the exponential definition of sine and do it that way too. First off, for the tangent, I need the gradient. So I'm going to differentiate this. I need to use the chain rule on this. So I differentiate the inside function. Differentiating ln 3x plus 1. The chain rule again on that, which gives us a 3 on the top, 3x plus 1 on the bottom. So that's differentiating the ln. So different side. Then I differentiate the outside. So shine differentiates the cosh. The thing inside the bracket stays the same. I'm putting in x is minus pi over 6. So 3 over 3 times minus pi over 6. 1 times cosh of ln 3 minus pi over 6. Not pi over 6, sorry, just a sixth. 1. And work this out. So gives me 6 on the outside, and I get cosh of ln of a half, which if we work that out will give us a nice answer. Gives me 15 over 2. I also need my y value, so y equals shine ln 3 times minus 6. 1. And if I work that one out, you get minus 3/4. Now we've got enough information to work out the equation. So I've got y minus y1 equals m x minus x1. So y plus 3 over 4 is 15 over 2x plus 6. It asked for it in the form, and we're going to assume it wants it in terms of integers. So let's expand this out. So 15 over 2x plus 15 over 12. Let's times through by 12. It's 15. And so we get 12y minus 90x minus 6 equals 0. Pause the video, have a go at the U-try, and I'll reveal the answer in a sec. Differentiating this using the quotient rule should give you this expression here. Set it equal to 0. Obviously, e to the minus x can't be 0. So you're solving cosh x minus sin x equals 0. That's the same as tan x equals 1. But this has no solutions because there's an asymptote at 1. So it turns out, actually, this has no stationary points.